What happens when a law of nature breaks? Not in the quiet confines of a blackboard where theorists chase phantom particles, but out there in the cold, unforgiving reality of space. We build our understanding of the cosmos on a foundation of unshakable principles, elegant equations that govern everything from the fall of an apple to the waltz of galaxies. These laws are our anchor in a universe of bewildering scale. They are supposed to be constant, universal, eternal. But on a night like any other under the silent watch of a mountain in Hawaii, humanity received a message from the void. A message that suggested our anchor had come loose, that the foundation of physics itself had developed a terrifying crack. The message arrived not as a signal, but as an impossibly subtle act of celestial defiance. It came in the form of a visitor, a traveler from between the stars, and it did something that nothing by all rights should ever be able to do. It just stopped. Our story begins not with that impossible moment, but with the quiet hum of machinery on the dormant volcano of Haleakala. Here, under skies so pure they seem like polished obsidian, stands a guardian. It is not human. It is the Asteroid Terrestrial Impact Last Alert System, or ATLAS, a sentinel of 4 robotic telescopes, 2 in Hawaii, 1 in Chile and 1 in South Africa, working in concert. Their collective mission is one of planetary defense, a tireless automated vigil against the existential threat of an asteroid impact. Night after night, they scan the entire visible sky, capturing vast mosaics of the heavens. They are built for speed, not detail. Their software designed to perform a cosmic dance of digital subtraction. They take an image of a patch of sky, then another, a short time later, and another. In a process of blink and you'll miss it comparison, the computer instantly identifies anything that has moved against the static backdrop of distant stars. The overwhelming majority of these moving specks are our neighbours' familiar asteroids in the main belt comets, on long looping journeys around the Sunday. They are known quantities, their orbits logged, their threat assessed. The system flags them, dismisses them, and moves on, sifting through terabytes of data every single night. It is a search for a needle in a haystack the size of the universe, a hunt for the faint signature of impending danger. But sometimes the sentinel finds a ghost, a whisper, a point of light that doesn't belong. It wasn't a catalogued asteroid. Its path was not the graceful elliptical curve of an object bound by our sun's gravity. This new discovery, flagged by the system in the early hours, was moving with a ferocity, a sheer velocity that spoke of a different origin. It was a cosmic outlier, a particle of stellar shrapnel on a hyperbolic trajectory, a path that meant it had come from the dark expanse between the stars, was paying our solar system a fleeting visit, and was destined to return to that same interstellar abyss. It would not be captured, it would not stay, it was just passing through. The alert rippled outwards from the automated systems in Hawaii to astronomers around the globe. Telescopes large and small swiveled to catch a glimpse of this fleeting guest before it vanished forever. This was only the 3rd such interstellar object ever detected in human history. The first, the bizarre cigar-shaped Oumuamua, had mystified us with its strange acceleration. The second, the more conventional Comet 2I, Borisov, had reassured us that our cosmic neighbourhood was sometimes visited by things we understood. Now came the 3rd, officially designated 3I, Atlas. It was a new chapter in a story we had only just begun to read, and initially it seemed like a familiar one. The world's observatories locked onto the faint traveller, gathering every photon they could. Spectrometers broke its reflected sunlight down into a rainbow of chemical fingerprints, revealing the secrets of its composition. The preliminary data painted a picture of a small, dark body, perhaps only a few hundred meters across. It was likely a silicaceous rock, a fragment of a planetesimal from a long-dead solar system mixed with frozen volatiles that were slowly beginning to vaporize as it drew nearer to our star's warmth. A faint, tenuous coma, a ghost of an atmosphere, was beginning to form around it. It was a classic rogue, a wanderer cast out from its home system by some ancient gravitational disruption, doomed to drift through the Milky Way for millions, perhaps billions of years. And like every other solid body ever observed in the universe, from the smallest asteroid to the most massive planet, it was rotating. Of course it was rotating. This is one of the most fundamental principles of celestial mechanics, the conservation of angular momentum. Think of a figure skater pulling in her arms to spin faster. The energy of her spin, her angular momentum, must be conserved. It can be redistributed, but it cannot simply vanish. In the frictionless vacuum of space, this law is absolute. An object that is spinning will continue to spin forever unless an external force, a torque, is applied to it. For 3i, Atlas, that spin was its celestial heartbeat. Astronomers tracked it by observing the subtle periodic fluctuations in its brightness. As it tumbled through space, it would present a larger face to our telescopes, then a smaller one, causing its light curve to rise and fall with a predictable rhythm. The data was clear, the period precise. It was completing a full rotation every 5.5 hours, a steady, stable, perfectly normal spin. It was the signature of a primordial momentum imparted to it at its violent birth in a protoplanetary disk orbiting a star you have never seen, a star whose light may have died out before life on Earth even began. For weeks, the observations continued. The light curve remained constant, a reliable metronome ticking away in the dark. We were getting to know our visitor. We were plotting its course, refining our understanding of its size and shape, cataloguing its predictable, law-abiding behavior. We believed we were simply observing another piece of the grand, orderly cosmic machine. We were charting the path of a ghost, yes, but a ghost that followed the rules. We were wrong. It was a ghost that was about to break the machine itself. The moment of discovery was not a sudden flash, not a dramatic explosion. It was far quieter and far more terrifying. It arrived as an absence, an anomaly in a data stream. On a Tuesday, the light curve from 3i, Atlas, was a perfect rhythmic sine wave. 5.5 hours peak to trough. On Wednesday, the data that came back was a flat line, just a steady, unwavering point of light. The initial reaction was mundane, predictable instrument error. A cosmic ray must have hit the sensor, a glitch in the tracking software, a miscalculation in the atmospheric correction algorithms. These things happen. The teams ran diagnostics. They rebooted systems. They waited for the next observatory halfway around the world to bring its own instruments to bear. The request went out, laced with a professional but urgent curiosity. Can you confirm our light curve data for 3i Atlas? We're seeing something strange. The hours crawled by. Then the confirmations began to trickle in. One observatory in Chile, then another in Spain. The data was identical. A flat line. The rhythmic pulse was gone. The celestial heartbeat had stopped. Imagine standing on a shore watching the tide. It comes in, it goes out. It is the rhythm of the planet. Now imagine that halfway through, coming in, the entire ocean just freezes in place. Not from cold, but as if the very concept of momentum had been switched off. This was the scale of the shock that washed over the astronomical community. It was a result that made no sense. In the vacuum of space, what could possibly have stopped its rotation? To halt a spinning object, you need to apply a perfectly calibrated opposing torque, a braking force. But where could such a force come from? Some immediately suggested outgassing. Perhaps jets of vaporizing ice erupted from its surface, acting like thrusters. But for that to work, the jets would need to fire with impossible precision in exactly the right direction, with exactly the right force, for exactly the right amount of time to counteract a spin that had been stable for eons. It would be like trying to stop a spinning carousel by randomly throwing tennis balls at it. The odds are not just astronomical, they are nonsensical. The energy required would be immense, and it would have to be applied in a way that left no other trace. The object hadn't shattered. It hadn't visibly changed its trajectory. It just stopped spinning. The law had been broken. Conservation of angular momentum, a principle so fundamental that it underpins our entire model of the universe, from star formation to planetary orbits, had been violated right before our eyes. This wasn't some subtle anomaly in the quantum foam or a theoretical paradox at the edge of a black hole. This was a macroscopic object, a rock hundreds of meters wide, performing an act of physical impossibility in our own cosmic backyard. The implications were staggering, and they cascaded through the scientific world like a shockwave. Frantic emails crisscrossed time zones. Theoretical physicists were pulled from their abstract calculations to confront a piece of raw, unbelievable data. Emergency meetings were convened. Preprint servers, where scientists post their initial findings, lit up with papers proposing ever more exotic explanations. Could it be an object of unnatural shape and density, a kind of gravitational gyroscope that had stabilized itself impossible under known physics? Could it be interacting with a magnetic field of immense and unknown properties? There was no evidence of such a field. Could the object itself be something utterly alien, something far beyond our current understanding of matter and energy? The questions spiraled into a maelstrom of confusion and exhilarating terror. Every proposed solution seemed to create more problems to require the invention of new physics that felt more like science fiction than plausible theory. The simple, observable fact that 3I Atlas was rotating, and then it was not, had become a kind of cosmic koan, a riddle posed by the universe itself. It was a direct challenge to the very core of our certainty. For centuries, we have looked to the heavens as a place of order, of majestic, predictable clockwork. But this visitor from the interstellar darkness suggested something else entirely. It hinted that the universe might not be a clockwork mechanism at all. It might be a place of deeper, stranger rules, a place where impossible things can and do happen. 3I Atlas was no longer just a curious rock. It had become a profound mystery, a messenger carrying a question that would force us to re-examine everything we thought we knew. It had transformed from a celestial ghost into a cosmic anomaly, a single point of light that held the power to shatter our most cherished laws. The great hunt for answers had begun an investigation not just into the nature of this one object, but into the very nature of reality. And the first step was to understand what could possibly wield the power to silence the spin of a world. For all of human history, our solar system was an island. We believed ourselves to be adrift in an impassable empty sea, the 9 planets, and their moons the only companions we would ever know. The stars were distant, untouchable points of light, their own systems locked away by gulfs of space-time so vast they defied comprehension. We were, for all intents and purposes, utterly alone, and then the first bottle washed ashore. It arrived in 2017, a whisper from the void that grew into a shout. We named it 1I, Oumuamua, a Hawaiian word for scout or first distant messenger, a name that carried all the weight of a paradigm shattering. It was nothing like we had ever seen. Telescopes across the globe strained to catch a glimpse of this fleeting visitor as it hurtled through our cosmic neighborhood on a trajectory that could only have come from another star. It wasn't a gentle arc, but a hyperbolic slash, a clear indication that it was not bound by our sun's gravity. It was just passing through. The little light it reflected back to us was baffling, a puzzle box tumbling through the dark. It appeared to be extraordinarily elongated, perhaps 10 times as long as it was wide, a cosmic cigar, or maybe a shard of some ancient shattered world. We never got a clear picture, only the frantic flickering of its light, a staccato rhythm that betrayed its bizarre shape and chaotic spin. It was dark, reddish, and utterly inert, showing no signs of the gassy halo, the coma that we expect from a comet warming in the sun's glare. Yet something was pushing it. As it swung around the sun and began its long journey back out into the interstellar darkness, it gently, inexplicably accelerated. A force other than gravity was acting upon it, a phantom push that defied our neat categories. Was it outgassing unseen molecules? Was its strange shape catching the solar wind like a sail? The questions multiplied with every new data point, echoing in the halls of astronomy long after Oumuamua had vanished back into the abyss. It left us with a profound, unsettling feeling the universe was not just larger than we imagined, it was stranger. The message in that first bottle was written in a language we could not yet read. Then less than 2 years later, a second messenger arrived. This one, 2I, Borisov, was different. If Oumuamua was an alien artifact, a ghost from an unknown realm, Borisov felt more like a distant cousin. Discovered by an amateur astronomer, it looked and behaved almost exactly like the comets born in our own solar system. As it neared the sun, it sprouted a magnificent dusty coma and a long ethereal tail. Spectrographs revealed familiar chemicals, the same building blocks of water and life that we find in our own cosmic backyard. Borisov was a profound comfort, It told us that the chemistry of our solar system might not be unique, that the processes that formed our worlds could be happening around other stars scattered across the galaxy like seeds on the wind. It confirmed that Oumuamua wasn't a fluke, a singular anomaly never to be repeated. The barrier between the stars was porous. The cosmic ocean was filled with these voyagers, tiny fragments of other solar systems making epic journeys across the interstellar deep. A new field of science was born in that moment: interstellar archaeology. For the first time, we didn't have to send probes on centuries-long journeys to study the makeup of other star systems. Pieces of those systems were coming directly to us. We were no longer islanders staring out at a blank horizon. We were beachcombers waiting with breathless anticipation for the next artifact to wash up on our shores, hoping the next message would be one we could finally decipher. We just needed a better way to watch the tide. We needed a guardian, a sleepless eye that could survey the entire ocean at once, capable of spotting the glint of a new arrival against the overwhelming darkness. That guardian already existed. It's called ATLAS, the Asteroid Terrestrial Impact Last Alert System. A pair of robotic telescopes, one in Hawaii and the other in Chile, operating in perfect synchrony. Their prime directive is not to search for interstellar messengers, but to protect us from ourselves, from the rocky debris left over from our own solar system's formation. ATLAS is our planetary defense system, a sentinel against catastrophe. Every single clear night, its telescopes scan the entire visible sky, taking thousands of pictures, charting the relentless dance of the asteroids. It's a monumental task of data processing, an automated search for anything that moves against the fixed backdrop of the stars. The system's algorithms are designed to flag potential threats rocks on a collision course with Earth, giving us precious time to react. It is a tireless, dispassionate watcher cataloguing the mundane orbits of countless familiar objects. But in its ceaseless vigil, it occasionally sees something more. It sees an outsider. And in the early hours of a cool January morning, a faint speck of light drifting through the constellation of Andromeda triggered an alert. It was just another new designation in a database of millions, a string of numbers and letters. The automated software, however, noticed something peculiar in its motion. It was moving too fast. Not just fast, but with a velocity that our sun's gravity simply could not contain. The initial calculations painted a trajectory so extreme, so open, that it could have only one origin: the vast, cold emptiness between the stars. The astronomical community erupted. Phone calls and emails flashed across time zones as telescopes around the world swiveled to get a look. This was it, the third one, 3I, Atlas. The excitement was electric, a palpable current running through observatories and universities globally. Oumuamua had been a fleeting glimpse gone before we could truly grasp what we were seeing. Borisov was a reassuring echo of our own system. But this new visitor, this third sample from the Galactic Library, promised something more. It was detected far earlier in its approach than the other two, giving us months, perhaps even years, to study it in unprecedented detail. This wasn't just another bottle on the shore. This was a vessel we could track, interrogate, and perhaps finally understand. The world's most powerful instruments turned their gaze upon it, dissecting every photon of light that journeyed from its surface to our mirrors. The initial spectra, the rainbow fingerprints of its chemical composition, sent back a truly perplexing signal. It wasn't a barren, rocky body like an asteroid, nor was it behaving like a classic water-ice comet like Borisov. It was a chimera, something in between, something new. There were hints of silicate rock, the stuff of planets, but they were mixed with the spectral signatures of highly volatile exotic ices. Not just the frozen water we know, but frozen nitrogen, carbon monoxide substances that can only remain solid in temperatures of unimaginable cold, far colder than the distant edges of our own solar system. This suggested 3I, Atlas, had been born in the frigid outer reaches of its home star system, a place far frostier than our own Kuiper belt. It was a pristine relic from the deep freeze of another world's dawn, a time capsule carrying the primordial chemistry of a place we may never see. This object was not just a rock, it was a message, and for the first time we had the tools to begin a proper translation. Every detail mattered, every subtle shift in its light was a clue to its origin, its history, its nature. And one of its most fundamental properties, one of the first things we measured, was its spin. From the very first focused observations we saw it, a gentle periodic variation in its brightness, a rhythmic pulse of light waxing and waning with clockwork precision. This is the celestial heartbeat of any solid object tumbling through space. As it rotates, it presents different sides to our view. A wider, more reflective face returns a brighter glint, while a narrower end or a darker patch causes the light to dim. By plotting these subtle changes over time, we create what's known as a light curve, a signature that reveals the object's rotational period. It's a technique we have perfected over decades, one of the most reliable tools in the astronomer's arsenal. For 3i Atlas, the light curve was exceptionally clear, a perfect repeating sine wave painted against the noise of space. The data pouring in from telescopes in Arizona, in the Canary Islands, in the high deserts of Chile, all told the exact same story. The object was turning on its axis once every 5.22 hours. 5.22 hours. Not approximately, not roughly, but with a metronomic regularity that you could set your watch to. The period was stable, consistent, and unwavering. Night after night, week after week, the rhythm held true. It was a cosmic gyroscope spinning with a momentum imparted to it perhaps billions of years ago, a physical memory of the chaotic environment in which it was formed. This spin was its most basic fundamental characteristic, as core to its identity as its mass or its chemical makeup. In the maelstrom of the early universe, something had set it in motion, and the sheer emptiness of interstellar space had preserved that motion perfectly. There was nothing out there to slow it down. No atmospheric drag, no friction, no external force to alter its majestic solitary pirouette. We modelled it, charted it, and predicted its pulse with unerring accuracy. This steady, predictable rotation became our anchor, the bedrock of our investigation. It was the one thing about this alien visitor that behaved exactly as our laws of physics dictated it should. A constant, a known quantity, a reliable beat in the great silence. We were documenting a perfect isolated system, a piece of celestial machinery operating according to the oldest and most trusted rules in the cosmos. We believed we were merely witnesses. We had no idea we were about to become detectives at the scene of an impossible crime. And so the first alerts were not sounded with sirens or panicked shouts, but with the quiet, blinking cursors of 1,000 confused computer terminals. In the sterile, climate-controlled data centers from Mauna Kea to the Atacama Desert, the same impossible signal began to filter through the noise of the cosmos. It was a whisper of impossibilities, a ghost in the machine that nobody, not a single seasoned astronomer, was prepared to believe. The initial reaction was universal, a silent collective denial. It had to be an error. The light curves from 3i Atlas, those delicate rhythmic graphs that charted its brightness as it spun through the void, had gone flat. Imagine listening to the steady, comforting beat of a cosmic heart, a rhythm you've traced for months across the abyss, only for it to suddenly, inexplicably become a monotone drone. The gentle rise and fall, the signature of a rotating body reflecting sunlight, had simply vanished, replaced by a perfectly unnervingly constant line. This wasn't a gradual slowing, a celestial object winding down like a toy top. This was an instantaneous, absolute cessation. One moment, a dynamic, tumbling traveller from another star system. The next, a statue hanging motionless in the interstellar dark. The first teams to see the data did what any good scientist would do. They assumed their multi-million-dollar instruments had failed. They ran diagnostics, combing through terabytes of telemetry, searching for the glitch, the sensor degradation, the software bug that would restore order to their universe. They checked the adaptive optics systems, the delicate mirrors that correct for atmospheric turbulence, suspecting that perhaps a subtle systematic distortion was smearing the signal, averaging out the peaks and troughs of the light curve into a flat line. Engineers were roused from their sleep, tasked with a digital forensic investigation of a machine operating perfectly on a remote mountaintop. They pored over diagnostic logs, tracing the path of every photon, from the primary mirror through the filters to the charge-coupled device. They were searching for a flaw, a human mistake, a simple rational explanation that could pull them back from the edge of this cognitive abyss. But every test returned the same maddening result: nominal. The telescopes were functioning with flawless precision. The atmosphere was clear. The data was clean. The error was not in our machines. The error, it seemed, was in the sky. A wave of cautiously worded emails and encrypted messages began to crisscross the globe. Are you seeing what we're seeing? This was the scientific community turning its colossal collective eye towards a single, impossibly small point of light. It became a global fire drill, a scramble to verify an observation that defied the very bedrock of their discipline. The Very Large Telescope in Chile swiveled its monolithic mirrors. The Keck Observatory in Hawaii held its breath. Radio telescopes designed to listen for the faintest whispers of the universe were retasked to search for any change in the object's thermal or radio signature, any clue that could explain the sudden silent stillness. They weren't just looking at it anymore. They were interrogating it, bombarding it with every observational technique in humanity's arsenal. From every continent, the answer came back a dreadful chorus of confirmation. The data was not wrong. 3I, Atlas, had stopped spinning. It hung in the void, locked in a state of perfect rotational equilibrium, as if a cosmic hand had reached out and held it still. With instrumental error ruled out, the investigation turned outward. Perhaps something had interfered with the light on its long journey to Earth. Could a foreground star precisely aligned be contaminating the signal? Astronomers scoured star charts and deep sky surveys, but the patch of sky was clean. There was nothing there, nothing bright enough to overwhelm the subtle signal of the traveler. What about a more exotic possibility, like gravitational microlensing? Perhaps an unseen object, a rogue planet or a cold brown dwarf had drifted between us and 3I. Atlas, its gravity bending the light in just such a way as to create the illusion of a static object. Teams ran complex simulations modeling the precise gravitational effects required. The models showed that such an event would produce a telltale, brightening a specific temporary magnification of the object's light. No such brightening had been observed. The constant flat line remained. Every door to a conventional explanation they tried was locked from the inside. They were being forced to confront the impossible truth head-on. To understand the depth of the crisis this created, we have to revisit one of the most fundamental, most sacred laws of the universe. It is a principle so deeply woven into the fabric of reality that everything from the spin of a child's top to the majestic swirl of a galaxy depends upon it. It is the law of the conservation of angular momentum. Think of an ice skater spinning on the ice. When she pulls her arms in, she spins faster. When she extends them, she slows down. Throughout this entire performance, a quantity, her angular momentum, remains constant. It is not created or destroyed. It is merely redistributed. The only way for her to stop spinning completely is to apply an external force, a torque, by digging the edge of her skate into the ice. The friction from the ice works against her rotation, bringing her to a halt. Now, take this principle and cast it into the cosmos. The universe is the most perfect vacuum we know, an almost frictionless environment. When a planet forms from a swirling cloud of gas and dust, the initial rotation of that cloud is conserved in the final solid body. Our Earth has been spinning on its axis for 4.5 billion years, a great gravitational gyroscope, because there is nothing in the vacuum of space of sufficient power to stop it. The Moon's gravity ever so slightly tugs on our oceans, creating a tiny braking effect, but this will take billions more years to have a truly significant impact. Galaxies, vast, spinning islands of stars have been turning for cosmic eons. Their angular momentum is a memory of their violent formation, a ghost of the initial spin of the universe itself. This law is not a suggestion, it is a cosmic commandment. An object in motion or in rotation stays that way, unless acted upon by an outside force. There are no exceptions. For an object like 3I, Atlas, to cease its rotation, it would need its own skate blade in the ice. It would need to be subjected to an enormous, precisely applied counterforce. So the international teams began a desperate hunt for this phantom force. What could possibly have arrested its spin? The most obvious culprit would be a collision. A catastrophic impact with another object could, in theory, halt its rotation. But for this to work, the collision would have to be a miracle of celestial mechanics. The incoming object would need to have the perfect mass, the perfect velocity, and strike 3I, Atlas, at the exact angle required to impart a torque precisely equal and opposite to its initial angular momentum. It would be like trying to stop a spinning bullet by hitting it with another bullet, not to destroy it but to leave it perfectly still in midair. The probability of such an event is so vanishingly small as to be functionally zero. Furthermore, a collision of that magnitude would be a violent, messy affair. It would create a brilliant flash of light detectable across the solar system. It would have generated a vast cloud of dust and debris, a shimmering halo of shattered rock and ice expanding outward from the point of impact. Our telescopes hypersensitive to such phenomena saw nothing. No flash, no debris. Only a profound, unnerving silence and stillness. The cosmic crime scene was completely clean. If not a collision, then what the next suspect was a process very familiar to astronomers outgassing. Comets are not solid, inert rocks. They are dirty snowballs. As they near a star, the heat causes ice beneath the surface to sublimate into gas, which then erupts into space through fissures and vents. These jets of gas act like tiny rocket thrusters. If they are distributed unevenly across the surface, they can cause a comet to spin, to tumble, and even to change its trajectory. So could a series of perfectly orchestrated jets have acted as a brake? Could 3I, Atlas, have stopped itself from the inside out? Again, the physics presented a near insurmountable problem. To cancel its rotation, the outgassing could not be random. It would require a set of thrusters on one side to fire, with exactly the same force as a set of thrusters on the opposite side, creating a perfectly balanced torque that bled off the object's angular momentum without sending it careening off course. This celestial ballet would need to be sustained with impossible precision until the spin reached zero, at which point all the jets would have to shut off simultaneously. It was a scenario that belonged more to science fiction than to astrophysics. Even if one were to entertain such a fantastical possibility, the evidence simply wasn't there. The immense plumes of gas and dust required for such a maneuver would be easily visible, forming a glowing coma around the object. Spectroscopic analysis would detect the chemical signatures of water vapor, carbon dioxide, and other sublimated ices. But 3I, Atlas, was stubbornly, frustratingly inert. It showed no coma, no tail, no hint of any outgassing activity whatsoever. It was, for all intents and purposes, a dead rock that had just performed an impossible trick. The investigators looked for other, even more subtle forces. Could tidal forces from a close flyby of a larger body have torqued it to a halt? This phenomenon, known as tidal locking, is why we only ever see one face of our moon. Over billions of years, Earth's gravity has slowed the moon's rotation until its rotational period perfectly matched its orbital period. But this is a gradual, agonizingly slow process that requires a massive gravitational anchor and immense spans of time. 3I, Atlas, was in the middle of nowhere, light years from its parent star and hundreds of millions of miles from any planet in our own system. Its trajectory was a clean, lonely arc through the deep void. There was no gravitational influence anywhere near it powerful enough to exert the kind of force needed to stop it, let alone to do so instantaneously. The sun's gravity was too uniform, the solar wind too feeble. Every avenue of inquiry led to the same brick wall. Every known physical law stated that what they were seeing could not be happening. And yet the data streaming in from around the world was relentless, unambiguous, and utterly conclusive. A new kind of mood began to settle over the astronomical community. The initial frantic energy of problem-solving gave way to a creeping, chilling sense of awe and dread. This was no longer an observational puzzle. It was a confrontation with an object that refused to obey the rules. Late-night video conferences were held between observatories, the faces of the world's most brilliant minds, pale and drawn in the glow of their monitors. The usual excited chatter of discovery was replaced by long, heavy silences. They were like cartographers who had sailed off the edge of their own map, finding not dragons but a place where the ocean simply stopped. The universe, which they had always believed to be governed by elegant, unbreakable mathematical laws, had just presented them with a miracle. And in science, a miracle is just another word for a terrifying anomaly, a crack in the very foundation of your understanding. The object 3I, Atlas, once a mere curiosity, a footnote in the catalogue of interstellar visitors, had now become the single most profound mystery in modern science. It was a 200-meter wide piece of rock and ice that was holding up a mirror to the entirety of human knowledge, and showing us a reflection we did not recognize. It was a cosmic monolith, silent and static, posing a question without words. The question was not, "Where did you come from?" or "What are you made of?" The question it posed was far more unnerving. It was asking, "Do you truly understand the rules of your own universe?" And with every passing motionless hour, the answer screaming back from the void was a resounding, deafening no. We had ruled out our machines. We had ruled out nature. We were left standing on the precipice of a new reality, staring into the darkness at an object that had, by some unknown mechanism, by some incomprehensible power, achieved the impossible. It had defeated one of physics' most sacred commandments. The search for an explanation was about to lead humanity down a path far stranger and more unsettling than anyone could have ever imagined. Because when you eliminate all the natural possibilities, you are forced to confront what remains, no matter how unbelievable. The next step was to start asking the forbidden questions. What unknown force, what new physics, or what intelligence could possibly have the power to simply stop a world from turning? The slowdown was no longer a curiosity, no longer a gentle drift from the expected. It had become a singular, obsessive focus for orbital dynamicists across the globe. Every new dataset from our observatories painted the same impossible picture. The great cosmic gyroscope, our interstellar visitor, was winding down. And as the last vestiges of its ancient spin bled away into the vacuum, the first wave of explanations began to crest, born of established, reliable physics. This was, after all, what science does. It confronts the unknown not with panic, but with a toolbox of proven principles. The most obvious tool, the one every astronomer reached for first, was sublimation. We'd seen this process play out countless times on comets born within our own solar system. Imagine the surface of 3I Atlas, a landscape of ancient frozen volatiles. As it journeyed closer to the sun, the star's warmth began to stir these ices, turning them directly from a solid into a gas, bypassing the liquid state entirely. This outgassing doesn't happen uniformly like a gentle, misty shroud. It erupts in violent, unpredictable jets, miniature cold gas thrusters. Each jet, a plume of vapor and dust, punches out into space with force. And a force, as Newton taught us, produces a corresponding change in motion. A jet firing off-center from the object's axis of rotation will impart a torque. It can speed the spin up, slow it down, or even make it tumble chaotically. This was the leading hypothesis, the comfortable, well-understood answer. The strange breaking of 3I Atlas had to be the result of a complex thermodynamic ballet, a perfectly choreographed sequence of these natural, unruly rockets. It was a beautifully simple idea, elegant in its reliance on known cometary physics, and for a short time it seemed poised to solve the entire mystery. Across the world, supercomputers were tasked with a singular, monumental challenge: prove that outgassing could stop 3I Atlas dead in its tracks. The first step was to build a virtual model of the object, a digital twin. Using the faint glints of light reflected from its surface, scientists pieced together a rough approximation of its shape and topography. They mapped its shadowed craters and its sun-drenched ridges, estimating where the most volatile ices like nitrogen and carbon monoxide might be lurking. These were the ices that would vaporize most energetically even in the faint warmth of the outer solar system. With this digital ghost of 3I Atlas constructed, the simulations began. They were intricate, painstaking calculations, modeling the angle of sunlight at every moment. The software would calculate which parts of the surface were heating up, predicting where and when a jet of sublimating gas would likely burst forth. Each virtual jet was given a thrust vector, a direction and a magnitude based on the composition of the ice and the intensity of the solar radiation. Then the laws of motion were applied. Could this specific jet firing from this specific crater at this specific time contribute to the overall reduction in spin? The teams ran thousands, then tens of thousands of iterations. They tweaked every conceivable variable, every parameter they could imagine. What if the jets were more powerful than expected? What if the ices were concentrated on just one side of the object? What if its shape was more like a dumbbell than a potato, allowing for greater leverage from the escaping gases? The digital models spun, slowed, and tumbled in virtual space for weeks on end. And for a tantalizing, while the results were promising, many simulations showed a dramatic reduction in the object's rotational velocity. They could replicate the initial slowdown with remarkable accuracy. The community breathed a collective, tentative sigh of relief. It seemed that classical physics, the familiar and the trusted, would hold. But then they tried to model the final act, the full stop. And that is where the elegant theory began to fracture. Getting an object to slow down is one thing. You just need to apply a counterforce. Getting it to stop perfectly to achieve a state of absolute rotational equilibrium is a problem of an entirely different magnitude. It requires a level of precision that nature rarely, if ever, provides. The jets in the simulations could bring the spin down to near zero, but the final moments were always a mess. A last, sputtering jet would inevitably fire at the wrong time from the wrong place, kicking the object back into a slow, lazy tumble. Another simulation might achieve a fleeting moment of stillness, only for a different patch of ice to heat up and nudge it back into motion. It was like trying to balance a spinning top on your fingertip by blowing on it from random directions. You might be able to slow it down, but the odds of blowing on it with such perfect symmetrical force that it simply stops and balances are astronomically small. The jets were a force of chaos, a symphony of random impulses. And chaos by its very nature does not compose a finale of perfect silence. To bring 3I, Atlas, to a complete and utter standstill, the outgassing would have needed to be a miracle of celestial engineering. A final, powerful braking jet would have to fire, and then at the exact femtosecond rotation ceased, every single volatile on the entire surface would have to become inert. All outgassing everywhere would have to stop simultaneously. It was a physical impossibility. The models proved it again and again. The beautiful, simple idea was failing. It could explain the slowing. It could not under any circumstance explain the stopped. With the prime suspect exonerated by the sheer force of computational evidence, the investigation was forced to turn toward more exotic, more subtle phenomena. The mood in the scientific community began to shift. The initial excitement of discovery was being replaced by a creeping, profound unease. If it wasn't the obvious answer, then the real answer had to be something far stranger, and so physicists began to look for a ghost. They searched for an invisible hand, a force that could reach across the vacuum and gently but firmly apply a perfect break to this spinning celestial wanderer. The first phantom they pursued was magnetism. We live inside a vast magnetic bubble called the heliosphere, generated by the churning molten heart of our Sunday. A complex web of magnetic field lines the interplanetary magnetic field, stretches out from the Sun, past the orbit of Neptune. Could 3I, Atlas, as it passed through this field, have been slowed by it? The theory known as magnetic braking or eddy current damping is sound physics. If an object is electrically conductive and it moves through a magnetic field, that motion induces electrical currents within the object, so-called eddy currents. These currents, in turn, generate their own tiny magnetic fields, and these induced fields fight against the external field that created them, producing a drag, a braking force that resists the original motion. You can feel this effect yourself if you move a strong magnet over a sheet of copper. You feel a strange viscous resistance as if you're pulling it through invisible molasses. Was it possible that 3I, Atlas, was in effect a giant piece of cosmic copper, and the Sun's magnetic field was the invisible molasses slowing its spin? The idea was tantalizing. Unlike the chaotic bursts of outgassing, a magnetic field could provide a smooth, consistent, and symmetrical braking force. It could, in theory, bring an object to a perfect, elegant halt. New models were spun up, this time incorporating the complex physics of magnetohydrodynamics. Spectroscopes were tasked with analyzing the faint light from 3I, Atlas searching for the telltale spectral signatures of metallic conductive elements. The search was on for the iron, the nickel, the cosmic wiring that would allow this to work, but the phantom of magnetism, like the theory of sublimation, before it soon dissolved under scrutiny. The first problem was composition. While the data was noisy, 3I, Atlas, appeared to be primarily composed of rock and exotic ices. It was a poor conductor. To generate the kind of eddy currents needed for this effect, it would have to be almost a solid chunk of metal, a relic from the shattered core of an alien planetoid. and every analysis suggested this was simply not the case. The second and more damning problem was one of scale. The Sun's magnetic field, while vast, is also incredibly weak at such distances. It is measured in nanoteslas, a billionth of the strength of a common refrigerator magnet. For this whisper-thin magnetic field to stop a body hundreds of meters across a body with the rotational momentum of a mountain spinning in space was a physical absurdity. It would be like trying to halt a speeding freight train by waving a compass at it. The numbers simply didn't add up, not by a little. They were off by orders of magnitude, by factors of millions and billions. The magnetic ghost vanished, leaving the mystery deeper and colder than before. The search grew more desperate, delving into the very fabric of gravity itself. Perhaps the answer lay in tidal forces. We see the power of tides in our own oceans, the daily pull of the moon and Sunday. But tides also affect solid bodies. The immense gravity of Jupiter needs its moon Io, like dough, generating enough friction in its core to power a hellscape of active volcanoes. Over eons, these same tidal forces can lock a moon's rotation, forcing it to forever show the same face to its parent planet as our moon does to Earth. Could a similar process, a subtle gravitational friction, have robbed 3I, Atlas, of its spin? Could the combined gentle pull of the Sun, Jupiter, and the other planets have been just enough to twist and flex the object, causing internal friction that converted its rotational energy into heat, bleeding it away into space until it spun no more? This was perhaps the most elegant theory yet proposed. It required no messy jets, no unlikely magnetic properties. It relied only on gravity, the most fundamental force in the cosmos. But it too fell apart against the hard wall of mathematics and time. Tidal forces are exquisitely sensitive to distance. They weaken dramatically as objects move apart. 3I, Atlas, was simply too small, its internal structure too rigid, and its distance from the Sun and planets too great for these forces to have any meaningful effect. The gravitational tugs it was experiencing were not a powerful kneading, but the faintest of cosmic caresses. The models showed that the amount of rotational energy dissipated by such forces was minuscule, almost immeasurable. Furthermore, tidal locking is a process of cosmic patience. It takes hundreds of thousands, if not millions of years to complete. 3I, Atlas, had gone from a steady spin to a dead stop in a matter of months. The timeline was wrong. The physics was wrong. The theory was a dead end. One by one, the pillars of conventional physics were being tested, and one by one they were crumbling. Every conceivable natural mechanism was proposed and subsequently discarded. Could it be the Yorp effect, the subtle pressure of sunlight itself, where photons striking the surface impart a tiny momentum? No, that force is fantastically weak, capable of altering an object's spin over geological timescales, not over a single season of observation. Could it have collided with a cloud of dust, a swarm of micrometeoroids? No such cloud was detected, and a collision violent enough to stop its rotation would have created a massive debris field, a brilliant flare of impact light. But the space around 3I, Atlas, remained pristine and dark. Could its interior structure have shifted a cosmic landslide, rebalancing its mass like a figure skater pulling in their arms? Plausible, but no model of internal collapse could account for the smooth, gradual deceleration and the final pow. Perfect stability. It would have produced a wobble, a chaotic tumble, not a clean stop. The scientific community had reached an impasse. They had fired every intellectual weapon in their arsenal, and the target remained completely unscathed, hanging silently in the darkness. The data was undeniable. The object had stopped rotating. The physics, as we understood it, was equally undeniable. It said this was not possible. This contradiction could not stand. The moment of reckoning had arrived. It came not in a single dramatic press conference, but in a series of solemn, coordinated presentations at a hastily arranged virtual symposium on small solar system bodies. The digital gathering was the who's who of planetary science, the greatest minds in celestial mechanics and astrophysics logged in from around the world. But the atmosphere was not one of triumphant discovery. It was heavy, somber, like a digital wake for a trusted friend, classical mechanics. The first presentation was from the team that modeled sublimation. They walked the global audience through their hundreds of thousands of simulations, showing elegant graphs of rotational decay that always fell short of a true zero. We cannot, under any physically plausible scenario, the lead scientist concluded, her voice tight with professional frustration, reconcile the observed rotational state with any outgassing model. The precision of the final state is, to put it mildly, non-physical. Next came the magnetics team. Their slides were filled with complex equations and field simulations. Their conclusion was even more blunt. For magnetic braking to be the cause, the presenter stated flatly, the interplanetary magnetic field would need to be approximately 1 million times stronger than it is, or the object would need to be composed of a material yet unknown to science. We find no evidence for either. Then came the tidal theorists, the collision experts, the internal structure modelers. Team after team from Pasadena to Paris to Tokyo took the virtual stage, and each of them told the exact same story. A story of exhaustive effort, of brilliant modeling, of countless hours of computer time. A story that ended in absolute unequivocal failure. You could feel the collective weight of their null results. It was a coordinated global admission of profound ignorance. They had treated this as a cosmic crime scene, and they had methodically investigated every natural suspect. All of them had unshakable alibis. The final summary was given by a revered figure in the field, a woman who had spent 50 years studying the dance of comets and asteroids. She appeared on the screen not with charts or graphs, but with a simple, stark message. For months she began, her voice echoing in hundreds of offices and labs. We have operated under the fundamental assumption that the behavior of 3I, Atlas, while unusual, would ultimately be explainable by the known laws of physics. She paused, letting the weight of that statement settle. Today it is the conclusion of this assembled body that this assumption is no longer tenable. We have exhausted every known mechanism. Sublimation, magnetic torque, tidal forces, radiation pressure, collision mass redistribution. Not one of these phenomena, either alone or in any conceivable combination, can account for the complete, stable and perfect cessation of this object's rotation. The words hung in the digital silence. It was a declaration of surrender, a white flag raised against a stubborn, inexplicable fact. She wasn't announcing a discovery, she was announcing the discovery of a boundary. A hard wall in our understanding of the universe. We are officially in uncharted territory, she continued, her gaze steady, unwavering. We are faced with an effect for which we have no cause. The universe has presented us with a locked room mystery. And we, the scientific community, are standing on the outside, holding a set of keys that do not fit the lock. There it was, the official peer-reviewed, globally sanctioned statement that our physics had broken. What do you do when the rulebook you have used to navigate the cosmos for centuries is suddenly shown to have a missing page? Where do you even begin to look for an answer when all of your tools have failed? The silence that followed her words was not just the absence of sound. It was the sound of 1,000 paradigms beginning to shift, of 1,000 comfortable assumptions beginning to crumble. And in that profound, unnerving silence, a new question began to form. A question whispered at first, then spoken with gathering urgency. If no natural force could have stopped 3I Atlas, what did the silence from our models was deafening? Every known law, every trusted equation, every carefully constructed simulation we had thrown at the enigma of 3I Atlas had led us to this same impossible wall. We had watched it enter our solar system, a messenger from the void tumbling like any other interstellar castaway. Then we witnessed it perform a feat that shattered our understanding of celestial mechanics. It simply stopped. The spin that should have been conserved, an inviolable law etched into the fabric of the universe, had vanished without a trace. There was no jet, no ejected mass, no magnetic torque from the sun that could account for this colossal theft of energy. Physics as we knew it had offered its final resounding verdict. What we were seeing could not be happening. And when the rulebook you have spent centuries writing no longer describes the game you are playing, you have only two choices. You can close your eyes and pretend the game isn't real. Or you can tear the book apart and begin searching for the ghost in the machine, for the hidden rules you never knew existed. For the astronomers and physicists staring into the void at this impossibly still object, the choice was clear. The doors to the comfortable halls of established science slammed shut, and a new, far more treacherous path opened before us. A path that led away from the well-lit landscape of the known and into the twilight realms of speculation where the monsters of theory lurk. We had to go there. We had to knock on doors we had long kept bolted to ask questions that felt more like heresy than science. The first of these new doors opened onto the very foundations of physics itself. For over a century, we have understood the universe to be governed by four fundamental forces: gravity, electromagnetism, and the strong and weak nuclear forces that bind the hearts of atoms. They are the pillars of reality. But what if there is a fifth A, force so subtle, so elusive, that it is hidden from our most sensitive instruments, revealing itself only under the most extraordinary circumstances? Some theorists began to wonder if 3I Atlas was that circumstance. Perhaps this object wasn't just rock and ice. Perhaps it was composed of or coated in some exotic material with a unique charge, not an electric charge, but a charge that responds to this hypothetical fifth force. Imagine a cosmic wind, a field that permeates all of space, yet one we cannot feel. It would be like a ghost current in a silent ocean, utterly undetectable to our ships and our nets. But if 3I Atlas were a vessel with a special kind of sail, a sail woven from matter that catches this invisible wind, then its bizarre behavior would begin to make a terrifying kind of sense. This fifth force interacting with the object's unique composition could have exerted a perfect counter-rotating torque. It would be a brake applied from another dimension of physics, a silent, unseen hand reaching out from the darkness to gently halt its spin. The idea was intoxicating. It offered an explanation that preserved causality that didn't require us to throw away Newton and Einstein entirely. It only required us to admit that our understanding of the cosmos was incomplete, that there was another fundamental layer to reality we had never peeled back. But this theory, as elegant as it was, carried an immense burden of proof. If this force exists, why has it only revealed itself now on this one object? Is 3I Atlas truly unique in the entire galaxy, a celestial unicorn made of a material found nowhere else? Or is this force so incredibly weak, so localized, that its effects are only visible on interstellar objects that have traveled through specific energized regions of deep space, becoming charged in a way our native asteroids and comets never could? The questions multiplied with every potential answer. Proving it would require a revolution, the discovery of new particles, new fields, a complete rewriting of the standard model that has been the bedrock of physics for 50 years. It was a tantalizing yet frustratingly remote possibility. This sense of frustration pushed some to look even deeper into the darkest mystery of the cosmos. For decades we have known that everything we can see, the stars, the galaxies, you and me, makes up a paltry 5% of the universe. The rest is a phantom realm. 27% is dark matter, an invisible scaffolding that holds galaxies together with its immense gravity. The remaining 68% is dark energy, a mysterious pressure that is relentlessly pushing the universe apart, accelerating its expansion. We know they are there. We can see their gravitational fingerprints on the cosmos, but we do not know what they are. They are cosmic ghosts passing through us, through the Earth, through the very heart of the Sun, without interaction, or so we thought. The new radical hypothesis was this: what if 3I Atlas is not as blind to the dark sector as we are? What if its material composition allows it to interact, however faintly, with the river of dark matter our solar system is constantly ploughing through? As the object spun, each side of it could have experienced a slightly different friction or pressure from this dark matter wind. This differential force, infinitesimally small but applied consistently over months and years, could have acted as a cosmic brake, slowly and precisely bleeding away the object's angular momentum until it reached a state of perfect equilibrium. It would be like a spinning top slowly coming to rest, not because of air resistance, but because of a force no one had ever imagined could exert friction at all. This idea sent a shiver of excitement and intellectual vertigo through the community. If this were true, 3I Atlas would be more than just a curiosity. It would be our Rosetta Stone for the dark universe. It would be the first tangible object, the first piece of hardware that connects our visible world to the vast invisible cosmos that surrounds us. It would be a key that could finally unlock the greatest secret of creation. But like the fifth force, this theory was an island of speculation in a sea of unknowns. We have no idea how normal matter could be made to interact with dark matter. The physics for it doesn't exist. To accept this, you have to invent not just one new phenomenon, but an entirely new branch of particle physics, a new form of interaction, a new category of matter itself. The explanation was almost as profound a mystery as the problem it was trying to solve. And so, after weeks of frantic work, the scientific community found itself in a state of quiet desperation. The conventional had failed. The speculative was untestable. Every path they had taken, every brilliant idea they had chased, had dissolved into a mist of unprovable assumptions. The object remained out there, a silent rebuke to human intellect, its impossible stillness, a declaration of our ignorance. It was in this moment of profound intellectual crisis, when all other doors had been tried and found locked, that a few brave or perhaps foolish minds dared to approach the very last door. The one no one ever wants to open, the one with a warning written on it in the starkest letters, "Times here be dragons, **." This door was built upon a single, terrifyingly simple question. We had spent all our time trying to understand how time's nature times could have stopped 3I, Atlas, from rotating. We had assumed from the very beginning that it was a natural object, a product of cosmic chance governed by the same impartial laws as every other rock in the sky. But what if that foundational assumption was wrong? What if the reason its behavior didn't conform to the physics of natural objects was because it isn't one? What if the force that stopped its spin was not some unknown law of the universe, but a known one, applied with deliberate intent? What if the answer wasn't new physics but old engineering? The thought once spoken hung in the air with the weight of a sacrament and the chill of a curse. The alien hypothesis. For centuries it has been the domain of fiction, the stuff of late-night talk shows and grainy photographs. But here, in the sterile environments of the world's most advanced observatories and theoretical physics departments, it was being uttered in hushed, serious tones. It was the last resort, the explanation you only turn to when every other conceivable option has been exhausted. And for 3I, Atlas they had been. The data was forcing our hand, compelling us to confront the most profound possibility in human history, that we were looking at a piece of extraterrestrial technology. To entertain this idea is to step across a threshold in our perception of the universe. You are no longer looking at a comet or an asteroid. You are looking at a machine, a probe, a cosmic shipwreck perhaps, or something else entirely. The mystery of the stolen rotation is suddenly reframed. It ceases to be a violation of physics, and instead becomes a demonstration of it. The question is no longer times, how could this happen times, but times, how did they do it times? The answer, of course, would require a level of engineering far beyond our own, yet it might still be grounded in principles we understand. Imagine for a moment the interior of 3I, Atlas. If it is a construct, it could contain vast internal flywheels, cosmic gyroscopes made of super-dense material. By spinning these wheels up in the opposite direction of the craft's rotation, a perfectly opposing torque could be generated. All of the angular momentum wouldn't have vanished at all. It would have simply been transferred, moved from the outer hull to the inner machinery, stored away like energy in a spring. It would be a brute force solution, but an effective one. A cosmic ballet of momentum exchange happening within a silent dark shell. From our distant vantage point, we would see only the impossible result, the spin stopping on a celestial dime. Or perhaps the solution is more elegant, more subtle. Advanced technology might not need to rely on such mechanical means. The object has been observed to have a slightly cometary tail, a faint outgassing of material. We dismissed it as far too weak to affect the spin. But what if that wasn't random outgassing? What if it was a network of precisely controlled microthrusters, a cold gas propulsion system of immense sophistication? Thousands of tiny, strategically placed vents could release puffs of gas, each one calibrated to impart a minute, counter-rotating force. Over time, these precisely orchestrated whispers of thrust too small for us to resolve individually would sum up to a powerful and exact braking mechanism. It would be technology mimicking nature so perfectly that we almost missed it hiding its engineered purpose behind a cometary veil. And then there are the possibilities that stretch our minds to their breaking point. Could this object be a demonstration of physics we can only dream of? A reactionless drive, a device that pushes against the very fabric of space-time itself by creating localized distortions in the gravitational field around its hull. Such a machine could generate torque without expelling any mass at all. It would be a form of cosmic levitation, manipulating the fundamental geometry of the universe to achieve its desired orientation. To us, it would look like magic. To its creators, it might be rudimentary transportation, a technology that could stop its own spin, could almost certainly propel itself, making 3I Atlas not just a passive drifter, but a vessel under active, intelligent control. This hypothesis, the idea of a builder, forces us to ask the next, and perhaps more important question, times why would a probe, a ship, a piece of technology from another star travel for thousands or millions of years only to arrive in our solar system and deliberately stop its rotation? The potential reasons are as staggering as they are unsettling. An object that stops spinning becomes a perfectly stable platform. From a stable platform, you can perform observations with unmatched precision. You can deploy sensors, you can unfurl antennas, you can aim a communications laser with pinpoint accuracy at a target a light year away. Was it orienting itself to get a better look at us, at the Earth? Was it turning to survey our entire solar system, cataloguing our worlds with the dispassionate gaze of a cosmic naturalist? Or perhaps the reason is even more profound. A non-rotating object is far more efficient at managing its energy. It minimizes thermal stresses and simplifies the operation of internal systems. Halting its spin could be an act of conservation, a powered-down hibernation mode entered after a long journey waiting for a signal or a specific time to awaken. It could be a navigational marker, a fixed beacon in a three-dimensional map deliberately placed in our system as a waypoint for others to follow. Its stillness might not be an end state, but a preparatory one, a quiet moment of calibration before its true purpose begins. We see an object that has stopped, but perhaps we are only witnessing a pause, a deep breath taken before the performance. To look at 3I Atlas through this lens is to feel a fundamental shift in your place in the universe. It is to feel the vast, cold, empty loneliness of space suddenly become something else. Not empty, but quiet. As if we have spent our entire existence shouting into a void we believed was uninhabited, only to suddenly see a light turn on in a distant window. The implications are almost too heavy to hold. It would mean that mind is not a planetary accident, but a cosmic phenomenon. It would mean that intelligence, creativity, and engineering have taken root in other soils under other suns. It would confirm that we are not the universe's only thought. The scientific method demands skepticism. It demands evidence. And the hypothesis of an alien artifact is for now just that, a hypothesis born of the failure of all others. It is an extraordinary claim, and it will require nothing less than extraordinary proof. But the object itself is extraordinary. Its behavior defies our physics, challenges our assumptions, and forces us to the very edge of our imagination. It leaves us with no other choice but to consider the possibility that we are staring across a gulf of untold light years, not at a dead piece of rock, but at the handiwork of another intelligence. The question of times, what times 3I Atlas is, has now been eclipsed by a far more pressing, far more terrifying inquiry. If this is a piece of technology, a messenger from the stars, how do we confirm it? How do we move from radical speculation to verifiable fact? How do you scientifically test for the presence of a mind you cannot comprehend? We must now search for the signs, for the telltale whispers of engineering that no natural object could ever produce. We have to find the technosignature. And so for years we were left adrift in a sea of speculation, each theory more desperate, more outlandish than the last. The silence from 3i, Atlas, was absolute, a perfect and profound void that reflected the growing emptiness in our own understanding. Science, our most powerful tool for dissecting the universe, had met a wall of sheer, featureless impossibility. Every model we constructed, every simulation we ran, shattered against the stubborn fact of its unnatural stillness. The object had become a monument to our own ignorance, a cosmic punctuation mark at the end of what we thought we knew. The debates in astronomical circles grew more heated, fracturing the community into camps of radical belief. Some clung to the hope of an undiscovered natural law, a fluke of gravitational harmonics, or exotic matter physics so perfectly balanced it seemed a statistical ghost. Others, in hushed tones and late-night forums, spoke of the unspeakable, the hypothesis that dared not speak its name in the hallowed halls of peer-reviewed science. The impasse felt total, a cold war of ideas with no victor in sight, leaving us with a silent artifact hanging in the darkness, and the disquieting feeling that the universe was hiding its deepest secrets behind an impenetrable curtain of physical law. We were stuck staring into an abyss that simply stared back, offering no clues, no comfort, no way forward. The crucible of conflicting ideas had burned itself out, leaving only the cold ashes of uncertainty. But even as the debate raged to a standstill on Earth, a new eye was preparing to open on the cosmos. An instrument born not from glass and mirrors in the traditional sense, but from the most esoteric and delicate principles of reality, itself. High in the Chilean Andes, nestled in the arid silence of the Atacama, the Cherenkov Gravitational Anomaly Detector, or CGAD, was breathing its first photons of starlight. This was not a telescope designed to see planets or galaxies. Its purpose was far more subtle, far more profound. CGAD was built to listen for the faintest possible whispers of space-time itself, the infinitesimal tremors left by the passage of immense mass or the expenditure of unimaginable energy. It operated on a principle of quantum interferometry, linking a vast array of supercooled crystalline detectors in a state of perfect quantum entanglement. Think of it not as a single lens, but as a planet-sized sensor, its constituent parts connected by the invisible, instantaneous threads of quantum mechanics. When a gravitational wave, a ripple in the fabric of reality, passed through the Earth, it would subtly alter the distance between these detectors on a scale smaller than a single proton. This microscopic disturbance, however, would be enough to disrupt their shared entangled state, creating a signal, a blip of decoherence in the otherwise pristine quantum silence. For years it had been a theoretical dream, an engineer's fantasy pushing the very boundaries of what was technologically possible. Its primary mission was to map the echoes of the Big Bang and hunt for the gravitational signatures of colliding black holes with a fidelity 1,000 times greater than any previous instrument. It was a tool built to probe the fundamental nature of gravity, to find the seams where Einstein's relativity might finally meet the strange, chaotic world of the quantum. 3i. Atlas was not its intended target. Observing such a small, distant, and apparently inert object was considered a waste of the observatory's precious time. It was only through the stubborn persistence of a junior research team who argued that no signal would be in itself a profoundly important piece of data that CGAD was turned toward the enigma. They were allocated a mere 12 hours of observation time, a pittance for such a revolutionary instrument, a token gesture to a group of young scientists chasing a ghost. They weren't looking for a bang, they were looking for a whisper, the faintest possible gravitational murmur that might betray some hidden internal process within the silent object. It was the longest of long shots, the ultimate fishing expedition in an ocean of cosmic static, a final desperate attempt to hear a sound in a perfectly soundproofed room. And for 11 hours and 59 minutes, that is precisely what they found. Nothing. An unnerving, impossibly flat line of data. A gravitational silence even deeper than its radiative silence. It seemed the final nail in the coffin of discovery, proof that 3i, Atlas, was exactly what it appeared to be, an object that simply inexplicably did nothing. Then in the final seconds of the observation window it happened. Not a shout, but the faintest exhalation of a breath. A tremor so minuscule, so fleeting, it was almost dismissed as systemic noise, a glitch in the nascent machinery. But the signal was there, buried deep within the data stream, a pattern of ghost-like coherence against the quantum chaos. It was not a continuous hum or a random fluctuation. It was a pulse, an impossibly slow, rhythmic, and perfectly repeating oscillation. A shudder, a flex in the space-time immediately surrounding 3I, Atlas expanding and contracting on a scale of mere nanometers, once every 87. 3 seconds, the object would minutely warp the space around it, a gravitational heartbeat so faint it was beneath the detection threshold of every other instrument on Earth. It was a motion so subtle it did not translate into rotation or even conventional vibration. Imagine a perfectly still bell that does not ring, but whose very substance gently breathes in and out so slowly and so slightly that the air around it barely stirs. This was the reality CGAD had uncovered. The object was not perfectly still after all. It was engaged in a form of micromotion, an internal periodic process that was bleeding an infinitesimal amount of energy into the universe as the gentlest of gravitational waves. The discovery sent a shockwave through the astronomical community, a jolt of electricity that reanimated the exhausted debate. This single, fragile clue, this whisper from the void, changed everything. It was the Rosetta Stone they had been waiting for, a key that, while not unlocking the ultimate answer, provided a way to finally begin translating the impossible. For the first time, they had a dynamic property to measure a behavior, to model a piece of active physics to dissect. The perfect stillness had been a featureless wall, but this rhythmic pulse, this was a crack in that wall, a thread to pull on a sign that something inside, 3I, Atlas, was alive with process. The object was no longer just a static mystery. It was a machine, and they had just heard the first faint turn of its gears. This single revolutionary piece of data became a great filter, a merciless guillotine for a dozen competing theories. The beautiful, intricate models of a perfectly balanced, naturally occurring object, a cosmic pirouette of forces holding it in stasis, were the first to fall. Nature, for all its elegance, relies on a degree of chaos. A natural system might find a temporary delicate equilibrium, but it would never produce a sustained metronomic pulse with the precision of an atomic clock. The 87.3-second interval was too perfect, too clean. It lacked the signature of natural decay, the slight wobble, the entropic drift that accompanies all physical processes. Nature almost never draws a perfect straight line, and this pulse was the straightest, most unwavering line anyone had ever seen. It was the gravitational equivalent of a pure, synthesized sine wave, not the complex, messy noise of a stellar flare or a planetary core. Next to the chopping block were the more exotic hypotheses, those involving strangelets, quark nuggets, or novel states of matter. While such theoretical materials might possess incredible density or unique gravitational properties that could explain the lack of rotation, none of the models predicted a stable periodic energy release of this kind. Their physics suggested they should be either perfectly inert or violently unstable, not engaged in a slow rhythmic breath. This pulse required an internal engine, a mechanism to cyclically generate and release this gravitational energy. A lump of exotic matter, however strange, is still just a lump. It has no engine, no moving parts, no internal clock. The micromotion observed by CGAD demanded complexity and internal structure that was actively managed and maintained. The idea of a quantum foam anchor, a bizarre scenario where the object was somehow locked to the very fabric of space-time at a subatomic level, also began to crumble. Such a connection should have been absolute. It would explain the stillness, yes, but it could not account for the pulse, which represented a clear interaction with and manipulation of the local space-time it was supposed to be anchored to. It was like finding a statue welded to the ground, only to discover it was gently tapping its foot to a silent, unheard rhythm. The two observations were fundamentally contradictory. One by one, the grand theories born of desperation and genius were invalidated by this quiet, insistent heartbeat. The data acted as an impartial judge, and the verdict was clear. 3I, Atlas, was not a natural fluke. It was not a passive relic of exotic physics. The process occurring within it was controlled, regulated, and deliberate, As the dust settled and the landscape of possibilities was cleared of its most familiar and even its most fantastic natural landmarks, only one conclusion remained standing, terrible and magnificent in its scope. The most speculative, the most derided, the most world-shattering of all the hypotheses was the only one that fit. The only model that not only survived contact with the new data, but was in fact predicted by its most advanced simulations. The evidence now pointed overwhelmingly in one direction. 3i, Atlas, was a work of engineering. It was a technology, an artifact. The periodic 87.3-second gravitational pulse was not a natural byproduct. It was the signature of a running machine. Suddenly, the impossible stillness was not a paradox to be solved, but a function to be understood. The object wasn't failing to rotate, it was actively, precisely, and powerfully preventing itself from rotating. It was engaged in a constant act of dynamic stabilization, a feat of engineering so advanced it bordered on magic. The leading model, once relegated to the fringe, now took center stage. It proposed the existence of an internal dynamic stasis system. Imagine a core composed of a spinning, superdense fluid or plasma, a kind of gravitational gyroscope manipulated by powerful force fields. This core would spin at near-relativistic speeds, but its effects would be perfectly contained and counteracted internally, cancelling out every external torque from solar winds or radiation pressure. It would be a system in a state of constant furious motion, a contained hurricane of forces, all for the purpose of maintaining a state of absolute external tranquility. This was not stillness born of balance, but stillness born of immense, perfectly applied and continuous power. And like any engine, it would not be 100% efficient. There would have to be waste, a tiny rhythmic bleed of energy. The 87.3-second pulse detected by CGAD was that waste product. It was the hum of the engine, the exhaust of a system manipulating inertia itself. The model refined with the new data made a chillingly precise prediction. The energy required to maintain this state, to counteract the minuscule but relentless pressures of interstellar space, was staggering. It was a continuous power output, equivalent to the total energy consumed by all of human civilization every single year, all focused on the single bizarre task of just staying still. The revelation reshaped the entire trajectory of the investigation. The question was no longer times, what times physical law allows this to happen. The question was now times, what kind times of technology makes this possible, and for what conceivable purpose. To what end would a civilization build a device of this scale, imbue it with a power source beyond our wildest dreams, and task it with doing absolutely nothing, with being the most profoundly unremarkable object in the cosmos on the surface, while hiding a storm of impossible physics within? Was it a sentinel, a border marker in a galactic empire, so vast we couldn't even perceive its edges? Was it a cosmic lighthouse, its gravitational pulse, a beacon for navigators who could read the ripples in space-time? Perhaps it was a prison, a perfectly stable containment field for something so dangerous it had to be locked outside of physics as we know it. Or maybe most disturbingly, it was a piece of automated terraforming equipment patiently waiting in a state of low-power hibernation for a signal to begin its work, a signal it had been awaiting for potentially millions of years as it drifted through the dark. The ambiguity was maddening. The faint pulse was both a revelation and a new kind of mystery. It was the first intelligible word spoken by the enigma, but it was in a language we could not yet comprehend. For the scientists who had dedicated their lives to this puzzle, the moment was not one of triumphant celebration. It was a moment of profound, humbling, and terrifying awe. They had set out to find a new law of nature, to add a footnote to the grand equations of the universe. Instead, they had found incontrovertible evidence that someone else had not only discovered those laws long ago, but had learned to rewrite them. We were no longer just astronomers, observing a celestial body. We were archaeologists who had just stumbled upon a pyramid, not in a desert on Earth, but in the cold, empty space between stars. And we had just detected the faint, rhythmic hum of the machinery, still running deep inside its unbreachable walls. The sense of isolation that had defined the human condition, the feeling of being brilliant, lonely minds in an empty cosmos, began to evaporate, replaced by something far more complex. A feeling of being very, very small and very, very new. The debate was over, but the real work, the real fear had just begun. Observing this object from a distance was no longer enough. The pulse was a clue, an invitation, perhaps even a challenge. It was a point of interaction, a potential vulnerability, a place to push, to probe, to see if we could elicit a response. The age of passive observation was over. The moment had arrived for a new and profoundly dangerous idea to take hold, a proposal to move from merely listening to the silent giant to reaching out and trying to wake it up. And so after the storm of frantic calculations and the digital fury of simulations, all collapsing into absurdity, we are left here. We are left in the profound, unsettling quiet that follows the exhaustion of all reason. Before us hangs the ghost of 3i, Atlas, a silent monument to a broken law, an interstellar traveler that completed an impossible journey only to perform an impossible act. It violated the most sacred, most fundamental promise of the cosmos, the conservation of angular momentum. It didn't slow down gracefully under some subtle, undiscovered force. It didn't crumble under the strain of its own rotation, bleeding its energy away into a cloud of sparkling debris. Having travelled for millions, perhaps billions of years, a spinning solitary gyroscope coasting through the unimaginable dark, it simply stopped. This is the unnerving endpoint of our epic pursuit, the final frame of a cosmic film that has run off its spool. We have walked you through every step of this bewildering detective story. You saw its first appearance, a faint smudge of light on a telescopic plate, just another wanderer from the cold abyss. You felt the thrill of discovery as its trajectory was painstakingly mapped, revealing not an orbit born of our own sun, but a path forged in the stellar winds of another long-dead star system, an immigrant from an unknown shore. We celebrated with the astronomers who meticulously measured its spin, a steady, predictable waltz that told a story of its ancient past. Then you stood with us, watching in disbelief as that story unraveled. We have descended into every conceivable rabbit hole of physics, chasing shadows and whispers of explanation. We explored the violent outgassing of hidden cryovolcanoes, searching for the perfectly balanced, impossibly sustained network of thrusters that could break such a colossal mass to a perfect standstill without sending it tumbling. The models failed, producing only chaotic wobbles, not this serene, supernatural stillness. We dove into the esoteric realm of magnetism, imagining a body so uniquely constituted that it could somehow anchor itself to the sun's own magnetic field lines, a cosmic grappling hook thrown across 90 million miles of vacuum. Yet the numbers screamed their dissent. The forces were 1,000,000 times too weak, the required material composition a fantasy of science fiction. We considered the subtle, patient touch of tidal forces, the gravitational stretching and squeezing from the sun and planets. But this explanation too evaporated under scrutiny. Such forces work over eons, grinding a spin down with the slowness of geologic time, not with the abrupt finality of a switched-off engine. We even ventured deep inside the object itself, into the realm of radical speculation. We imagined strange internal sloshing of a liquid core, a complex redistribution of mass, a mechanical reconfiguration so perfectly orchestrated it could nullify its own external motion. But this requires a level of internal engineering, a coincidence of material and motion so fantastically improbable it borders on the miraculous. Every theory, every elegant equation, every desperate hypothesis we presented to the universe as a possible key was rejected. The lock, it seems, is not one we recognize. The door does not open. Our failure to explain 3i, Atlas, is not a minor footnote in the annals of astronomy. It represents something far more profound, something that strikes at the very heart of the scientific endeavor. For centuries, we have built our understanding of the universe upon a scaffold of inviolable laws. These principles, gravity, electromagnetism, the conservation of energy and momentum, are the bedrock of our reality. They are the intellectual tools that allow us to plot the course of a planet, to predict the light of a distant star, to build the technologies that define our modern world. We have long assumed them to be truly universal, as true in the first second after the Big Bang, as they are today, as reliable in the Andromeda Galaxy as they are in the falling of an apple here on Earth. 3I, Atlas, stands in silent, cold defiance of that grand assumption. It suggests a terrifying or perhaps exhilarating possibility that our laws are not absolute. They may only be local ordinances, the bylaws of our particular cosmic neighborhood, effective and true in our corner of the Milky Way, but perhaps naive and incomplete when confronted with a true stranger from afar. This object, by its very existence, by its simple, inexplicable act of ceasing to spin, has torn a hole in the great tapestry of physics we have so carefully woven. Through that tear, we see not a new, elegant design, but a void, a question mark that hangs over everything we thought we knew. This is the paradigm shift it has initiated. The certainties of the 20th century have given way to the profound humility of the 21st. We are forced to confront the idea that the universe might not just be more complex than we imagine, but more complex than we can times imagine with our current understanding. It is a humbling experience, one that echoes the moments in history when we first realized the Earth was not the center of the universe, or when we discovered the bizarre, counterintuitive world of the quantum. Each of those revolutions in thought was preceded by an observation that simply did not fit a rogue planet in its orbit, a flicker of light that refused to obey the rules. 3I, Atlas, is our rogue, our flicker of impossible light. And what of the human cost of this mystery? Think of the scientists you have met on this journey. These are individuals who have dedicated their lives to the elegant pursuit of cosmic order, who find beauty in the mathematical precision of the heavens. For them, this object is both a source of infinite fascination and profound professional torment. They rerun their data, check their instruments, and redesign their simulations, haunted by the possibility of some simple overlooked error. But there is no error. There is only the data, cold and stark and absolute. They are the guardians of a mystery they cannot solve, the keepers of a secret the universe has told them, but which they cannot translate. Imagine the long nights spent staring at screens filled with equations that lead nowhere, the passionate debates, in sterile conference rooms that end not in consensus but in a shared, frustrated silence. This is the friction of true science. It is not a clean, linear march toward truth. It is a messy, often maddening stumble through the dark, guided by the pinpricks of light, from things we can measure but cannot yet comprehend. And yet, within that frustration, there is an undeniable spark of excitement. Because a puzzle like 3I, Atlas, is the greatest gift the universe can offer. It is an invitation. It is a challenge that will ignite the careers of the next generation. Somewhere right now is a young student just beginning their journey into physics, a child looking up at the night sky for the first time, whose mind will one day formulate the question we are not yet clever enough to ask. 3I, Atlas, is their inheritance. It will be the object against which new theories are tested, the anomaly that inspires the development of new kinds of telescopes, new forms of propulsion, new ways of probing the cosmos. Its legacy will not be an answer, but 1,000 new questions that will push our species further out into the intellectual frontier. Will we need to rethink the nature of inertia itself? Is there a form of energy exchange with the vacuum of space, a friction with the fabric of space-time that we have never before detected? Was the object interacting with a form of matter that is invisible to us, a particle or a field that belongs to a sector of physics still completely hidden from our view? Could it be an artifact? The thought is both tantalizing and dangerous to a scientist. A piece of technology from a civilization so advanced that its methods of motion control are indistinguishable from magic. A piece of cosmic driftwood whose internal engine finally sputtered and died as it passed through our solar system. We have no evidence for such a conclusion, none at all, but in the utter absence of any natural explanation, the silence of 3I, Atlas, allows the mind to wander into these forbidden territories. It forces us to acknowledge that the assumption of an empty, lifeless universe is just that, an assumption, not a fact. So where does this leave us, you and I, at the end of this journey? We are left staring out into the darkness, forever changed by what we have seen. You can no longer look up at the night sky as just a collection of predictable clockwork lights. You now know that it is a place of deep, abiding mystery, a realm where the impossible can happen. You know that among those placidly burning stars and wheeling galaxies, there are things that defy our most cherished truths. 3. I, Atlas, is a potent reminder of our true place in the cosmos. We are not the masters of this universe, confidently armed with a complete rulebook. We are newcomers, just beginning to read the first chapter, and we have just discovered the text is written in a language we barely understand. It teaches us that scientific truth is not a destination. It is a horizon we are constantly walking toward. The goal is not to have all the answers, but to be brave enough to face the questions. The inexplicable cessation of this object's rotation is more than a data point. It is a piece of cosmic philosophy. It tells us that there will always be more to discover, always another layer to peel back, always a deeper mystery waiting to humble us and to inspire us. It is the universe's way of keeping us curious. Out there right now, 3I, Atlas continues its silent journey back into the interstellar void. It is no longer a spinning top, but a gravitational tombstone carrying its secret with it into the unending night between the stars. It may never again pass through a solar system with intelligent beings capable of noticing its strange passage. Its moment of revelation, our moment of profound confusion, may be a singular event in its billion-year life. We were simply lucky enough to be here, to be looking in the right direction at the right time, to witness the impossible. We now stand on a different shore of knowledge than we did before its arrival. We are less certain, but infinitely more curious. We are more aware of the vastness of our ignorance, but more hopeful about the potential for future discovery. This single solitary rock has become one of the most important objects ever observed, not for what it told us, but for what it failed to tell us. It is a cosmic enigma, a catalyst for a revolution, and a permanent haunting whisper from the great unknown. A whisper that reminds us with chilling, beautiful clarity that the most wondrous secrets of the universe are not the ones we have solved, but the ones that for now remain completely, utterly, and magnificently beyond our comprehension.